All right, hello everyone. Welcome to my channel. This is an educational channel where we look at various theories of everything in detail. And today is the 307th video that we've done on Dewey B. Larson's reciprocal system of theory. And the basic idea behind the reciprocal system of theory is that we live in a universe that is made entirely of motion. And other people have made that claim in the past, in history. Luminaries such as Rene Descartes and Thomas Hobbes and Arthur Eddington have all proposed a universe made out of motion. But what distinguishes Mr. Larson's theory is that he defines motion as the relationship between space and time. And that sets up a generalized reciprocal relationship between space and time. Space and time basically are have no independent existence. They only exist in motion. And they are basically the numerator and the denominator of a fraction. And so motion is a fraction or a ratio with space or time as the numerator and time or space as the denominator. Such as speed. Speed is the most basic kind of motion that we're familiar with. Speed is space over time. The bike is moving 15 miles per hour. That is speed. And that is 15 miles of space in 1 hour of time. Another form of motion that we're familiar with is acceleration. Acceleration is space over time to the second power. I dropped that rock out of the third-story window, and it fell at 9.8 meters per second squared. 9.8 meters of space and 1 second squared of time. Time over space over time to the second power. Now, there are also many other scientific quantities that we maybe don't associate with motion that are in fact motions and that are space over time relationships or time over space relationships. Such as energy. Energy is actually the inverse of speed. Energy is time over space. It took me 3 hours to move that thing 25 feet. 3 hours of time and 25 feet of space, energy. Or matter. Matter is time to the third power over space to the third power. Or pressure. Pressure is time over space to the fourth power. And so on. Now, Larson in the late 1950s, he put out his two fundamental postulates. And that is the core of his theory. And then from those postulates, he deduced a theoretical universe upon which he wrote a lot of his books. And that first postulate is the most important. Basically, the universe is made out of motion. Motion is the relationship between space and time. Space and time both have their coordinate aspects, meaning that space and time are both, now, they both are identical, except that they are reciprocals of each other. So whatever property one has, the other also has. And space and time both have their coordinate aspects. We recognize the coordinate nature of space, three-dimensional space, x, y, z coordinates. Well, time also has 3 dimensions. Maybe they're not x, y, z coordinates, but they're something analogous to x, y, z coordinates. And then we generally recognize the progressing nature of time. Larson calls this clock time. the clock is always getting later and later and later. What this is what Larson calls a scalar motion. This is a motion that has a magnitude, but it has no specific direction, such as a clock. The clock is getting later and later and later, but in no specific direction. But this clock time is also extended to space. Clock space is the fact that things are getting farther and farther and farther apart. And you can envision this using a balloon with dots on it. You blow up the balloon, all the dots are moving farther and farther and farther apart, but in no specific direction. And that is what Larson calls clock space. So you've got coordinate time and clock time, and you've got coordinate space and clock space. And then you also have both time and space as being discrete or quantized, meaning that they come only in individual units. There's no continuity there. They come in chunks. You either have a full chunk of something or you don't have anything. It's kind of just like an orange. Well, maybe that's not a good example. But you know, an entity, you either have a full entity or you don't have anything. You know, you can cut an orange in half, but basically, you know, off the tree, you either have a full orange or you don't have anything. You know, there's no 0.26 oranges growing off the tree. That may be just a terrible example, so you might want to just forget that. But the basic idea behind space and time is that they are discrete. They come in full units. And if you have exactly 1 unit of space in 1 unit of time, recalling that space over time is speed, 1 unit of space in 1 unit of time is the speed of light, which Larson calls unit speed. 1 over 1 equals 1. So in Larson's system, unit speed is the kind of the background or the origin of the universe. It is the null point or the state of rest, which makes sense in a universe of motion. Motion comes before everything else. So if you subscribe to a universe of motion, you have to subscribe to the general idea that motion precedes everything else. And so in Larson's universe, in a universe where you have nothing, you have motion. Motion is the ground from which everything else springs. So motion is the 0 point, so to speak. Whereas in legacy science, 0 is the 0 point, 0 motion. And you measure motion plus or minus as, you know, +1, +2, +3, +4, +5. And you measured negative motion, that is in the other direction, -1, -2, -3, -4, -5. But in the reciprocal system, use reciprocals, and that entails mathematics. That entails multiplication, or you know what you would call a geometrical progression. So you have 1 at the center instead of 0, and on the positive side you have plus, you know, 2, 3, 4, and 5. On the negative side, you have 1/2, 1/3, 1/4, and 1/5. So the numbers multiply to 1 to balance them out. If they're balanced out if they multiply to 1, whereas in the legacy science, they balance out by adding to 0. So that's a fundamental difference. Also, Einstein, you know, says that the speed of light is the maximum speed of the universe. In Larson's system, the speed of light is the midpoint of the universe. That's the one unit speed. And then half the universe is moving faster than the speed of light. That's a 2, 3, 4, and 5. And then and he calls that the cosmic sector. And half the universe is moving slower than the speed of light. 1/2, 1/3, 1/4, 1/5. And that's the material sector, and that's the sector we're familiar with. These two sectors are identical, except that they are reciprocals of each other. You have to invert or interchange the roles of space and time. So in the material sector, you have coordinate space, 3 dimensions of space, and clock time, progressing time. And in the cosmic sector, you have coordinate time, 3 dimensions of time, and you have clock space. Space is always getting farther and farther and farther apart. So that is a little bit about how the system works. You also have, you have this boundary, the speed of light boundary, and when you cross that boundary, the rules change. But you also have 2 other boundaries there. One is called the unit space boundary, and one is the unit time boundary. Okay, so you have the unit speed boundary, the unit space boundary, and the unit time boundary. The unit space boundary is if you don't have a full unit of space. Anything less than a full unit of space, and you don't have space, by the discrete unit postulate. And if you don't have space, that means you only have time, because the universe is made out of space-time or motion. And so if it's not one, it's the other. Or, it could be both, but one or the other. So if you don't have space, then you only have time. Larson refers to this as the time region. And so this is the region where the phenomena, the action, is within 1 unit of space. Such as your microscopic phenomena, your atomic and molecular phenomena. And so too, and that's in the material sector. In the cosmic sector, you have the space region, which is within the time unit time boundary. If you don't have a full unit of time, then you don't have time. If you don't have time, then you only have space. Larson calls this the space region, and this is the region of all the action that occurs in less than 1 unit of time, which incidentally is incredibly small, 1.52 times 10 to the minus 16 seconds. And this is the realm of cosmic atoms and cosmic molecules, microscopic, or what you'd say maybe instantaneous, or near instantaneous action, sphere of action. So when you cross those boundaries, you also invert the rules. The rules change when you cross any of those 3 boundaries. And so those are important things to consider as you consider the reciprocal system. Now, as I said, Larson came out with those postulates in the late 1950s, and then wrote books through this process of deduction, deducing a theoretical universe from that fundamental postulate, and the second one, which has to do with math and geometry only. And then, wrote books on chemistry and physics and astronomy, and also economics, and some stuff on biology and metaphysics and philosophy and religion and psychology. And then, unfortunately, he died in 1990. He left behind a small group of dedicated researchers who were determined to keep up his work. And many of them wrote a lot of different articles, a few books. Among them was, well, I'd say, foremost among them, at least for me, were Dr. KVK Nehru and Dr. Bruce Perret. They eventually kind of collaborated on what they call RS2, the Reciprocal System 2, the re-evaluation of the reciprocal system, where they revised a few of the areas where Larson made a few mistakes, which Larson admitted that he was subject to error. Larson said the system itself is correct. Whether I have applied the system correctly is a different matter. And so this has to do with his derivations, his deductions from the postulates. Now, I go through the 165 steps that Larson takes to derive his theoretical universe in about 15 videos that I did maybe about 8 months ago, 9 months ago. It's called The Outline of the Deductive Development of the Reciprocal System. This is a talk he gave way back when. So you might want to go over those to see Larson's thinking step by step by step. And then, anyway, Perret and Nehru put together, extensions of Larson's reciprocal system. So they revised a few key concepts, but they stayed within the spirit of the system, with the system itself, not necessarily with all of Larson's conclusions. And they extended the Larson system to other subjects. Now, in this particular article that we're looking at from Nehru, he's writing on linguistics. It's language, experience, and illusion. This is the third video that we've done on this subject. And so you might want to go back 2 days to go to the very beginning. But we're at a section here that's called the Rupa and Arupa levels. Benjamin Lee Whorf, the linguist, recognizes two principal levels in a language: structure, the Rupa, and Arupa levels of the plane of Manas. He identifies the lower level with the process of giving names to the parts of the whole flux of experience, with the Rupa, or the realm of name and form meaning organization in three-dimensional space. By naming, these parts are made to stand in an artificial isolation. See, for example, how the words hill or swamp entice us to regard them as referring to discrete things in themselves, while in truth they are nothing more than local variations in altitude or soil consistency, as the case may be. The next level of language he calls the level of patternment, and identifies with the Arupa levels of mind. Arupa, formless, means that there is no reference to the spatial form or the visual shape, which is the salient feature of the Rupa levels. It is a realm of syntactical patterns and grammatical structures. Whorf notes, such patterns, quote, such patterns are not like the meanings of words, but they are somewhat like the way meaning appears in sentences. Because of the systematic, configurative nature of the higher mind, the patternment aspect of language always overrides and controls the lexation, or name-giving aspect. The context or sentence pattern determines what sort of object the word refers to. For example, the sentence, I hold it, has the same pattern as that of I lift it, I push it, or I hit it, all of which depict overt action. However, hold does not imply any action or movement. It is rather a statement of relative positions. Nonetheless, we imagine, nay, we see, hold, depicting action in the above sentence. This is simply because the proposition is set up on the same pattern as that of the other examples that do denote action or movement. The formula substantive plus verb equals actor plus his action is implicit in our sentence structure. This pattern prompts us to read into nature non-existent actors or agents simply because our sentence structure, when not imperative, demands a substantive for a verb. We say it rains when rains itself suffices for the reality. We set up an actor, it, to perform the action. To quote Worf, Hopi can have the Hopi Indians, Hopi people, Hopi can have verbs without subjects. We unknowingly project the linguistic patterns of a particular type of language upon the universe and see them there, rendered visible on the very face of nature. A change in language can transform our appreciation of the cosmos. Science has not yet freed itself from the illusory necessities of common logic, which are only at bottom necessities of grammatical patterns in Western Aryan grammar, necessities for substances, which are only necessities for substantives in certain sentence positions, necessities for forces, attractions, etc., which are only necessities for verbs in certain other positions, and so on. James Jeans, or Jeans, I don't know, the astronomer Royal, quoting Bertrand Russell, states, quote, grammar and ordinary language are bad guides to metaphysics. In illustration, he mentions Descartes, who thought that there could not be motion unless something moves, nor thinking unless someone thought. This view springs from a notion, usually unconscious, that the categories of grammar are also the categories of reality. Quote, when it had become clear that light was of an undulatory nature, physicists argued that if there were undulations, there must be something to undulate. One cannot have a verb without a noun, and so the luminiferous ether became established in scientific thought as the nominative of the verb to undulate, and misled physics for over a century. End quote. When Dewey Larson propounded the reciprocal system of theory, the first completely successful general theory of physics, which postulates that the most basic and the only constitution of the physical universe is motion, scientists came up with the same objection that there can be no motion without anything moving. It took quite some time for them to realize that in a universe of motion, the primary entity ought to be motion, and that all the things of the universe, matter, electricity, magnetism, radiation, gravitation, etc., are different manifestations of the primary motion. The noun-dominated languages, with their tendency to objectify and isolate, are well suited for the conceptualization and the progress of science. But in the same proportion, they cause us to recede from reality. Okay, that is the end of that article. Yeah, you know, if you come to accept the reciprocal system of theory, you have to be able to accept the fact that you can have motion without something moving. Motion is not only does it precede anything that's moving, but it actually is anything moving as well. Motion precedes everything. So you have to be able to kind of clear that out in your head, or just accept it without argument, just to start with. You can reject it later, but in order to consider the reciprocal system properly, I think you have to get to that point. Just one more thing that I would add, which I added in a couple of videos ago also. Benjamin Lee Whorf, the linguist who did his studies on the Hopi and I think maybe some other Native American tribes, he in the early to mid 20th century has those two Rupa and Arupa levels of language. Now, at least from like studying Tree of Life, there would be a third level of language, which is language as power, specifically as power. No meaning, just power. This is where you would classify mantra. So if you're chanting mantra, you're using syllables, but those syllables don't have meaning; they have power. So they're meaningless. They convey a certain type of energy, power. Actually, power in the reciprocal system is, with your space-time coordinates, is 1 over s. Power is 1 over s, 1 over space, or the inverse of space, which would be time. But power is just, in language, is the stark, just core aspect of language. It's kind of like if you are a tennis player and you serve, you make a grunt, a sound, when you're trying to put some extra oomph into that, but you use a particular sound, and you don't use a different sound. There's a certain sound that you make if you want more oomph, but there's, maybe a different sound that you make if you want to relax, or, if you're angry. These are sounds that they don't specifically have meaning. They have power. So anyway, and so that might also affect the idea of language. If you have 3 different dimensions of language, maybe you will be able to equate those with 3 dimensions of time, coordinate time. That's just speculation on my part. Okay, well, we will take over with a new article tomorrow. And thanks for tuning in today. Have a great day.